Imagine a world where you never have to worry about having to recharge your battery, where you can power your devices with the air around you, where you can communicate without any external sources. Sounds amazing, right? Well, this is not science fiction. This future-like technology is a reality. In today's Odyssey, we will explore the world of battery-free devices. What does this battery-free technology have in store for our future? So, how did they come up with this idea? You may be surprised to know that they were inspired by the history of radio technology, which dates back to the 19th century. Back then, inventors like Nikola Tesla and Guglielmo Marconi experimented with wireless transmissions of electricity and information using electromagnetic waves. They envisioned a world where wireless power and communication would be ubiquitous and free for everyone. However, they faced many technical and practical obstacles, such as finding a way to harvest enough energy from weak signals, designing devices that could operate with intermittent power, and ensuring reliable and secure communication. The researchers from the University of Washington decided to revisit this vision and overcome these challenges using modern technology. Before we dive into the process of how battery-free devices work, let's meet the brilliant minds that pioneered battery-free technology: Joshua R. Smith, Vincent Liu, Shyamnath Golakota, and Aaron Parks. They published their groundbreaking paper in 2013, demonstrating the first battery-free devices that could communicate over long distances using ambient signals. They also founded a company called Jiva Wireless, which is developing commercial products based on this technology. The researchers from the University of Washington have published several papers on their invention, which you can find in the links below. They have also shared some of their blueprints online for anyone who wants to try it out themselves. So then, how does this technology work? Let's use an analogy to understand it better. Imagine you are in a dark room with a flashlight and a mirror. You can use the flashlight to send messages to someone else in the room by turning it on and off in a certain pattern. This is similar to how traditional radio communication works. You need a transmitter that generates a signal and a receiver that detects it. Now, what if you don't have a flashlight, but only a mirror? Can you still send messages? Yes, you can. You can use the mirror to reflect the light from another source, such as the sun or a lamp, and modulate it by tilting the mirror in different angles. This way, you can create your own signal without generating any light yourself. This is similar to how ambient backscatter communication works. You don't need a transmitter that generates a signal, but only a device that reflects and modulates an existing signal. RF signals are like invisible light that is emitted by various sources, such as TV towers, cell phones, Wi-Fi routers, or Bluetooth devices. These signals are everywhere around us, and they carry information and energy. Unlike how solar power technology works, battery-free devices use antennas to pick up these signals and convert them into small amounts of electricity, which they use to modulate and reflect the signals with encoded data. This technique is called ambient backscatter communication, and it allows battery-free devices to communicate with each other or with other RF-enabled devices. Now that we know how battery-free technology works, you may be wondering, how much power can battery-free devices generate? This is where the challenges start to arise. This depends on several factors, such as the distance and orientation of the device from the RF source, the frequency and strength of the RF signal, the efficiency and design of the antenna and circuit, and the interference and noise in the environment. According to some studies, battery-free devices can generate up to a few milliwatts of power, which is enough to run low-power devices such as sensors, tags, or microcontrollers. However, this power output may vary depending on the conditions and requirements of each device. One of the most important challenges is security and privacy. Since battery-free devices share the RF medium with other devices, they may be vulnerable to eavesdropping or jamming by malicious actors who want to intercept or disrupt their communication. For example, someone could use a powerful transmitter to block or overwrite the RF signals that battery-free devices use to communicate, or someone could use a sensitive receiver to capture or decode the data that battery-free devices send or receive. To prevent these attacks, battery-free devices need to use encryption and authentication techniques to protect their data and identity. However, these techniques require more power and computation than what battery-free devices can afford. Therefore, researchers are working on developing new methods and protocols that can provide security and privacy for battery-free devices without compromising their performance or efficiency. Now that we have covered the challenges that battery-free devices will have to face before they can revolutionize the future of our technology, in this next section, we will explore the tangible impact of battery-free devices. One of the most impressive examples of battery-free devices is the world's first battery-free Game Boy, which harvests both solar energy and the user's kinetic energy from button mashing to power an unlimited lifetime of gameplay. This device was developed by researchers from Northwestern University who wanted to demonstrate the feasibility and fun of battery-free gaming. They even managed to play Tetris on it without any batteries or wires. Another amazing example of battery-free devices is this wireless passive sensor that can measure temperature, humidity, light, and motion without batteries or wires by using ambient backscatter communication. This device was developed by researchers from the University of Washington who wanted to create a low-cost and maintenance-free sensor for IoT applications. The device uses an antenna to harvest and reflect RF signals from nearby sources, such as Wi-Fi routers or cell phones. The device also uses a microcontroller and a sensor chip that consume very little power. The device can send data to a nearby receiver, such as a smartphone or a laptop, without any batteries or wires. A third remarkable example of battery-free devices is BF-free, a system that enables makers to build and program battery-free devices with Python. This system was developed by researchers from Delft University of Technology who wanted to make battery-free devices more accessible and user-friendly for hobbyists and enthusiasts. The system consists of a power failure-resistant version of Python called PyLeap and an energy-harvesting hardware shield called BeFree Shield. The system allows users to write Python code for battery-free devices using common libraries and modules such as GPIO, ADC, PWM, I2C, SPI, etc. The system also allows users to use various sources of energy harvesting, such as solar, thermal, or kinetic energy. These are just some of the examples of battery-free devices that are making a difference in the world. There are many more examples that you can find in the links below. Battery-free devices are not only cool and fun, but also practical and useful. They can solve many problems and create many opportunities for wireless communication and sensing. And guess what? Analysts predict that this technology will create a $30 billion industry by 2031. That's huge. We have now reached the end of exploring this discovery. By reimagining how we power and connect technology, researchers are pioneering solutions that will shape our future in profound ways. Thank you for embarking on this enlightening discovery with us. We hope you found it both enjoyable and informative. Don't forget to subscribe to our channel. It's a different form of bookmarking so that you can see our other videos. By looking at challenges in new ways, we take bold steps forward into the unknown. Who knows what amazing discoveries await around the next corner? But one thing is clear. The energy surrounding us is limitless if only we can find the key to unlock its potential. See you in the next Odyssey.